If you've completed the previous steps correctly, you should now see the funnel plots in step 7.1. In this plot, studies are plotted on the x-axis, which represents the effect size, and on the y-axis, you'll see a measure of precision, often the standard error. If there's no publication bias, the plot should form a symmetrical inverted funnel shape. This shape indicates that larger studies, which are more precise, are found towards the top, while smaller, less precise studies tend to spread out more widely. If you'd like to delve deeper into interpreting funnel plots, I recommend reading the article referenced as Reference 1. In addition to the standard funnel plot, there are various other versions, such as the trim and fill method funnel plot shown in step 7.2. Utilizing this plot is optional, so you can decide if it adds value to your systematic review. The trim and fill method is beneficial for assessing publication bias. It addresses the issue of missing studies by estimating and including potential unpublished studies' effect sizes. This approach can give a more accurate overall effect representation and mitigate bias due to absent studies. However, bear in mind that the trim and fill method relies heavily on the assumption of a symmetrical funnel plot, which doesn't always hold true. It will attempt to correct any asymmetry, regardless of whether it's caused by bias. As a result, there's no guarantee that the adjusted effect reflects what might have been seen without publication bias, since the real causes of such bias are often unknown. Additionally, this method does not address other sources of funnel plot asymmetry beyond publication bias. Therefore, it's best not to use this method if there is high heterogeneity among the studies. When interpreting the trim and fill funnel plot, recognize that it includes both filled data points, which represent the actual studies included in your analysis, and trimmed data points, which estimate what additional missing studies could look like. If the funnel appears symmetrical after filling and trimming, it suggests that there may not be significant publication bias affecting the results. However, if the plot is asymmetrical, this may indicate potential publication bias, suggesting that studies with negative or non-significant results are likely unpublished. Next, consider how the estimated filled studies might influence your overall effect size. This provides insights into the robustness of your findings. Also, review the spread of studies in the plot. If there's high heterogeneity, it might suggest differences in study designs, populations, or interventions. In step 7.3, you'll see another optional plot, the radial plot. If the center line is horizontal at y equals 0, it indicates that the intervention has no effect. The upper and lower lines represent confidence limits, creating a 95% confidence interval. If there's little heterogeneity, 95% of the studies should fall within this region. Studies that fall outside this area are considered outliers. Finally, in step 7.4, you can perform statistical tests to determine if the funnel plot is actually asymmetrical. For generic tests, you should choose either Begg, Egger, or Thompson. For binary outcomes, select Harbord, McCaskill, Peters, or Schwarzer, and for standardized mean differences, go with Pustejovsky. It's crucial to remember that these tests require at least 10 studies to run. You can choose the type of test for each outcome, and if the p-value is less than 0.05, it indicates that the funnel plot is asymmetrical.